right. So, some more in situ tests which can be done on concrete, non in situ test related to durability. So, one is initial surface absorption test, it is a British code test. What you do is you have a constant head reservoir, right, 200 is 200 mm, 20 centimeter. So, nothing but a funnel and there is a pipe. Now, there is a you can close it, there is a clip or tap here which can close this. This is a kind of a watertight clamped to surface, right. So, this gets filled with water to start with, and this is same height as this, and there is a capillary tube where any flow of water can be measured. Now, what you do, you saturate this first and then hold it. After 10 minutes you open this and see the rate of flow through this in terms of milliliter per meter square per second, right. 10 minutes, 30 minutes, 1 hour, 2 hour sorry. This is called initial surface absorption test. Higher this value, concrete is more permeable, in other words it is poorer concrete. All qualitative, no quantitative, nothing you can really say about how long your repair cycle will be, etc. There is something called fixed air permeability test, something called fixed water permeability test. I will describe one of them. So, fixed air permeability test, what you do? You drill a hole here, and this is a rubber seal, hole drilled onto the concrete surface. Height is around 40 mm and this is 20 mm, up to 20 mm you have a silicon rubber seal, right. So, in situ silicon rubber seal plus foam plastic plug. Then there is a hypodermic needle, injection needle you pass through it, and this is connected to a hand vacuum pump, and this is to a meter, this is to a meter. So, what you do? You evacuate this portion, you evacuate this portion of the concrete. Now, this is 10 mm, 20 mm, 40 mm, you just evacuate this portion up to something like 55 kilopascal vacuum or 60, and then close the tap at let us say 55 kilopascal. Now, what will happen? The vacuum will get reduced. How? The air will enter from this side into this cavity from the side and vacuum will get reduced. Vacuum pump you have stopped at 55 kilopascal, minus 55 kilopascal, and then air will enter through this, and note the time at which it has gone to 50 kilopascal or some such values, over a range. So, if this time is high, it means that concrete is less permeable. If it is low, it means that it is high permeable. So, again qualitatively you can measure the permeation quality of concrete. There are many other tests which have come of late, autoclamp test, torrent tests, several of them, right, several of the permeation tests have come, but all give you some qualitative idea. So, you want to compare one concrete with another concrete, it is possible. In fact, one of the ideas is that by the side of your structure, you put some concrete specimen, dummies, and from time to time measure this, observe them and measure them, and they can be linked to the performance of the structure. So, performance based design, some measurements you can do, some in situ measurement, but some dummies also you can use, not an easy job, but you can do it in some important structures. So, all these permeation tests, two of them I described. There is another BS absorption test. What you do? You cut a 75 mm core and put it in an absorption test in distilled water for half an hour in some standardized procedure. The amount of absorption, if it is high, it is a bad concrete, high permeability, moderate permeability and low permeability. So, this way it can be classified. For example, ISAT 10 minutes, if it is less than 0.25 milliliter per meter square per second, then it is low permeable. If it is 0.25 to 0.5, then it is moderate, and if it is more than 0.5, then it is highly permeable. So, you might put your criteria that it should be at least, should not be below, above this value. I missed out one test, DIN, DIN test is a German, now it must be EN test. So, what they do? They actually subject a cube, water, the subject a cube under hydraulic head. That means apply water pressure from one side, not this side, right. I mean, or even for 3 side, does not matter, I mean the code would tell you how much it is. Then what you do? You find out how much, then you split this, do a split test. Like we do in cylinder, we can do split test in cube also. What you do in case of split test in cube? Apply a line load, right. This is your cube, apply load along this line, right, apply load along this. So, it will split. So, you split it and find out what is the depth of penetration of water. Now, time of applying this hydraulic head is fixed, amount of hydraulic head is fixed, the depth of penetration is a measure of permeability. So, it is finished in 3 days, something of that order, So, 1 day 4 millimeter, 4 day test, millimeter is given, it is given 4 day test, millimeter, DIN 1048, 1045, I think. There are, like the German codes gives you this. So, less than 30, it is good, more than 60, it is highly permeable. So, BS water absorption test less than 3%, 3 to 5%, greater than 5% is bad, and modified fixed air permeability, which I showed. So, this is actually I have used at site sometime, we have used at site, because it is simple. Core, you take out core, but then it is semi destructive, you can say. ISAT also we have used in site. So, other kind of tests that one can do is laser generated complete elevation of building. It could look like this. Today people can use drones to do visual survey, it has been done. Then wireless, pass on the information, but a transducer has to be what we talked about, and what is the purpose, that is more important. You have to decide why you are doing this, what you want to do, what is the objective, and what inferences you want to get. That part is important. The drone or those instrumental technology would not tell you that, but you have to select the right kind of transducer and all that. So, using laser steel structure one can actually totally obtain. So, these are some of the non-destructive testing and some of the other tests involved in generally condition assessment of building structure and finding out even repair cycle some cases, right. The one of the advanced stuff is structural health monitoring, which uses different kind of sensing. Sometimes they would like to measure the response to dynamic load, right, and find out how the stiffnesses are changing and all that. So, those are more mechanical, damage detection related, there are subjects based on those. Many of them would look into mechanical aspects, but deterioration aspect is where the maintenance is. Damages you can determine by various techniques actually, or structural health monitoring cannot tell you about at the moment, because the transducers are not available for deterioration measurement, right. If there is a damage that has occurred, let us say due to earthquake, that possibly stiffness would change, some other cracks have come. Damage is different than deterioration. Deterioration is a gradual process. I think I must have given you the definition earlier. Damage is due to loads, it is related to load. So, this people do use everything synonymously, that is not correct. Retrofitting, rehabilitation, repair, all are not same thing. I think I have given you definition. Similarly, damage, deterioration, they are different issues actually. Deterioration can lead to long term, long term deterioration can lead to damage, but damages are usually quickly they come during accidental overloading, earthquake, Sometimes fatigue damage could be there over a long period of time in where the stress reversal is there. So, that is it, that is related to this. Now, we will look into some strategies. So, as I said that people do muddle up with definitions of repair, rehabilitation and retrofit. I might have given you once, but let me repeat it again. Repair relates to restoring the functional performance to an acceptable level. That is what we defined earlier also, and we talk in terms of patch repairs, small areas repair. Rehabilitation is for the complete structures, like something like renewal we talked about, the link between our maintenance strategies we discussed about. And retrofit is currently acceptable standard, retrofit to a currently acceptable standard, means nothing may have gone wrong, but still you might do a retrofitting because it is not up to the currently acceptable standard. We define maintenance, etc. So, retrofit fits into that sort of thing, right, even though functionally it is performing fine. Like example is of course in structural scenarios that seismic risk perception has changed. Risk perception has changed, not really anything else have changed. So, you think that you should strengthen it or do something more, more capacity increase or whatever it is you want to do in some manner, or detailing you want to improve. So, sometimes strengthening is required if you find the actual structure is weak, then whatever it should have. So, that is strengthening. So, repair, retrofit, rehabilitation and strengthening. Strengthening may be a part of the last retrofit as well as rehabilitation also, right. Then some more definitions. Damage can occur due to loading beyond capacity. Damage or distress can occur due to deterioration or degradation of material leading to serviceability limit failure, right. So, this can occur over a long period of time. So, most often degradation of material do not lead to collapse, but you need a maintenance. It would cost of maintenance would be there. So, sometimes people get really scared. For example, you find a crack at the parapet level, between the parapet and the slab level of the roof, or the floor top roof top level, parapet where parapet starts. You try to find a horizontal crack. People get scared. Is the building going to get collapsed? Perhaps not. You got to do this. Similarly, if you see a corrosion cracks, one rebar or couple of rebars showing corrosion, signs of corrosion cracking, it does not mean that structure will immediately collapse. You do not attend them, then it will collapse. So, you have a lot of time available here, and therefore, this is related to maintenance, more rather maintenance than collapse scenario, right. So, this is what it is. Did I define the life before? So, life is, as I already defined you. So, life we have already defined. Now, the deterioration etc. related to durability. So, they should perform, concrete structures should perform safely unless deteriorated by environment. So, when we talk of deterioration, durability is related to deterioration, and it shall survive and serve the function during the period of intended design life. That is what we have seen earlier also. So, you might need periodic and occasional maintenance, that is what is the point. So, some strategy has to be defined with regard to this. We have looked into non-destructive testing, and we have also seen importance of inspection etc. in case of other components of buildings. So, if you look at structural element, then also we have this issue. So, we will look into this. So, let us define durability first. Now, durability is defined, or its capability to maintain minimum performance level for a specified period of time in a given environment where you have exposed it, right. So, it must be able to show performance, functional performance, whatever it is supposed to do. Supposing it is supposed to carry load, it should be able to carry the load, or if there is load performance is one of them, and there could be other performances as well. So, deterioration and degradation is related to durability in this manner. So, it is the capability to maintain minimum performance for a given period of time in a given environment where deterioration can occur. Performance are measures of the fulfillment of functions, whatever it could be, and performance varies with time. Deterioration is gradual decrease of performance with time. Now, structures or materials will really they will decay because they are man made, produced at the expense of energy. So, they will actually show some sort of decay because you have they are not at stable minimum chemical potential level. So, all material system produced at the expense of energy will deteriorate. So is the case of structures, and therefore, you must maintain them to currently accepted standard, same concept. Hence, there is a need for appropriate maintenance management principle. We have defined service life earlier, I think we defined this service life earlier. So, that is what it is. So, maintenance strategy we have to write. Now, maintenance policies could be alternative maintenance policies could be possible, something like this, that you use a material or a system which deteriorates, then you repair, bring it back to original state, again it goes and goes and goes. So, you do several repair in the life of the structure, but this is very cumbersome because the cost involved will be also include disruption costs and sort of it is an uncomfortable scenario for the user. So, you may not actually do the repair exactly at the serviceability limit, maybe some normally accepted level you might do the repair, but a good repair would do, it would be such that you won't need any further repair. Once you have repaired, the deterioration process will slow down and it will reach to the intended design life. In fact, you should have maintenance free service life, maintenance free life, intended design life of the structures, because this maintenance do cause a lot of disruption cost, discomfort. It is not something is cracked, people do not feel very comfortable about it, and you have to repair, the cost involved is too high. So, all these issues are there. Now, this can still happen because you cannot envisage the environment, deterioration environment truly 100% truly envisage the situation is not very easy. So, if there is a deterioration occurring, you repair it in such a manner that it goes up to the end, that is the idea. Now, in this such situations, of course, we have already looked into life cycle cost sometime, but here this is slightly more elaborate, I believe, than the equation that I gave you earlier. So, there is an initial cost, this is more important for various kind of structures. Now, there is a cost related to quality assurance, which could be different for different level of quality control. Quality assurance, it can be different. So, it is the pure initial cost. Construction quality maintenance cost is something like this, which occurs in the beginning. So, this is all in present worth form. Now, this cost are inspection cost. So, you got to do periodic inspection, that is what we have seen in case of other components of building, right. So, inspection cost, then there is a maintenance cost, and then you can associate with the probability of failure, serviceability limit failure probability, and then cost of serviceability limit failure. The probability of failure in first year, second year or 5th year, 10th year, etc., others should be 0 anyway, and you can multiply this. So, this is the probability P, PLF is the probability of doing the repair, and which is we have seen in case of buildings, roof covering and things like that all of them will not be done in the same time. So, even structural elements, if there is a possibility of deterioration, since they will not be done, out of 100 only 20 buildings showed problem or 20 structures showed problem. So, probabilities can be associated in this manner, and then this is the interest rate and time. So, R is the interest rate, Ti is the that particular year. So, I going from 1 to n for all n years. So, repair cost is, there is a repair cost, this is the repair cost, and this is the probability of cost of failure. If there is a failure, even after doing repair, so damages it might even you might have to pay a lot or rebuild or whatever it is. So, this kind of a model one can think of for the life cycle cost, including the probability of failure and things like that, right. So, generally inspection is a must. What I am trying to show here is that there is a good system of maintenance would involve inspection, right. So, inspection is must. Now, obviously, the quality is very important, that is what we have seen so far. Environmental condition, also loading condition is important. Loading condition is important, because a fatigue loading one would be more susceptible to damages rather than where you have static load. So, the last two factors are too important, environmental condition and loading conditions, right. Even if this is good, then also one must look into this. So, exposure environment, basically it should include both environmental and loading. Exposure environment, because loading environment is important. Well, things like IS 456 or the prescriptive ones do it for durability, take care of durability in the beginning. But when you are looking at inspection, we simply classify them as aggressive and non-aggressive environment, and loading is static and fatigue, because I said the fatigue could be more dangerous. So, you think in terms of exposure environment, you have very severe exposure environment, considering both loading and both loading and environment. So, if it is aggressive environment with cyclic loading or fatigue, then I call it very severe situation. If it is aggressive environment with static loading or non-aggressive environment with cyclic loading, then I call it severe, and normal means non-aggressive environment with static loading. So, which are actually aggressive environment? Supposing I have a thermal power plant in coastal area, there are one or two in Gujarat, right. Now, or some factories, for example, cement factory, Ambuja cement factory is in almost seashore. Now, the very close to the sea, the chloride can come by aerosol, movement of the aerosol. They can come and actually accelerate the process of river corrosion. So, this is definitely an aggressive environment, or where wetting and drying is occurring, right. Wetting, drying is occurring, and then non-aggressive would be, non-aggressive would be this kind of situations are not there. Cyclic loading, and this is well understood, stress reversal is there wherever it is. So, then we we define also importance of structure. If the structure is very important, I should inspect it frequently, more frequently, then a structure is not so important. For example, a boundary wall, even in aggressive environment, I may not see it every year. But if it is a nuclear reactor structure or a turbine generator room, I better inspect it every more frequently. So, that is what it is. So, we define importance of structures. So, first is importance of structure is, first one is vital importance to the community, can lead to disaster, catastrophe, lot of people may die. This is important to community, failure may cost life. This is somewhat moderate, considerable importance, and class 3 is unimportant, right. So, what the strategy suggested for inspection is something like this. It is suggested, inspection interval is suggested something like this, that if it is environmental and loading condition, exposure is very severe, severe, normal, class 1 is most important structure, not so important structure, less important structure and not so important structure. So, if it is class 1 type of structure, you must do inspection every 2 years if it is in very severe, like the example I was giving, thermal power plants close to seashore, right, or all over those coastal areas of the country, or something similar, because it can also damages, stop the power supply to many places. So, that kind of situations, even it could be major bridges, strategic bridges. So, for example, there is only one bridge in 1962 war, 62-65 war I think, between north of Assam and south of Assam, Saraigat Setu, he knows about that. So, Brahmaputra, over Brahmaputra. So, there is only one and it has to be protected. If you do not protect it, part of it gets disconnected, no supply to those areas. So, that is very strategic. So, this should have been, maybe now there are many more, but all of them are actually class 1 type. Bridges are usually long bridges, they are class 1 type, because they can cause a lot of that decision has to be made. Then class 2 are some sort of community halls and things like that, that kind of structures which are of considerable importance, can be catastrophic. One has to make decision related to this, which one you want to classify, how important. Nuclear reactor, and they will automatically fall into those. So, here you do 2 years inspection every year, routine. Routine means generally mostly visual, but some small instrumental. Extended means highly instrumental, lot of instrumental you might do depending upon the situation, what you envisage, what you visualize, what is the kind of deterioration possible, what are the damages possible. So, extended is basically instrumental. So, you have 2 years, every 2 years you have routine, that means this year I do routine and 2 years later I will do again routine, but in between year I will do actually extended. So, every year I am doing in this kind of situation, class 1 with very severe, you do every year inspection, 1 year routine, next year extended, which means that maybe you use more instruments, like drone survey and things like that. I mean, depending upon whatever is available, how you want to look at it, how much money you want to spend on the whole thing to save the repair cost later on. If it is class 2, same 6 years, that means every 3 years you will do something. 3 years once routine, next 3 years later you do extended, again 3 years later. So, in between years you just do routine between 2 extended cases. And if it is class 3, not so important structures, 10 years. And if you come down this way, you do not do anything, superficially you look at it. And if it is in severe environment, I mean normal condition, normal, not severe, normal environment, this is 10, 10, that means every 5 yearly you will be doing something, and here you do not have to do even anything. So, this could be a suggested strategy by experts, European experts actually, and one can follow this kind of strategy. Quantifying, modeling them is not easy, then you got to know the deterioration rate, which is still a grey area of our research, all right. So, because you remember economics I talked about, so cost growth and damages are like this, right. So, repair cost increases with time in non-linear manner, cost was increasing in non-linear manner, okay. And timely survey and inspection can result in saving. So, average repair, if you are doing inspection every T years, average repair time will be T by 2, it will not be more than that, because either you will pick up yesterday the deterioration has started, you have picked up today, or you have missed today, inspection you have done, it starts tomorrow. So, on an average one can think in terms of T by 2. Total cost of survey and repair of the summary, one can minimize this cost, but I think I will not go into that model. That model needs, that kind of a model would need actually finding out the rate of deterioration. So, inspection cost increases in this manner, repair and disruption cost will decrease. There is an optimal point, but quantifying them is still a challenge at the moment, quantify how much deterioration will occur at what time is a challenge. If you know that, then you can easily model this. So, total cost minimization one can do. Continuous monitoring is nothing but is a special case where my inspection time is 0. I am monitoring continuously. So, T is equals to 0. So, one can model this as I was saying, but then the TMRS is expected repair cycle time. One can model this actually from those cost curves, but then you got to know optimal and also rate at which actually the CMT is the increase of repair cost for a delay of 1 year. This kind of model one can obtain, right. T is the optimal inspection time. You can simply write the equation and differentiate it.